So today we're going to be converting the unit circle. We understand what the unit circle is, and we're going to be converting this into something that looks like an elementary trig function, a sine, a cosine, and a tangent wave. Now, what we've seen previously is we've seen a lot of mathematical analysis of the unit circle is. So the first thing of what we're going to be doing today is we're actually going to be creating the unit circle, which is going to come from your notes in a previous video. However, because we don't want to spend the entire video going and filling out all of that, what we're going to do is we're going to go ahead and fill out the first unit circle that we have so that we have a good grasp on what exactly we're converting. So we have a set of degrees that we're going to call, this is going to be our 0 degree. And where exactly do I want to put this? Let's put it right here. So 0 degrees is our flat line. This is our base. Can't tell that at all, so I'm going to pick a more vibrant color. And from this line, all other lines on the unit circle created. So we have our 0 degree, we have our 30 degree, we have our 45 degree, we have our 60 degree, we have our 90 degree, and we keep going all the way around until we reach the end. Perfect. And so now that we've gone all the way around in the circle, we're going to go ahead and do the same thing with radians as well. Except we're going to do radians in a different color. Let's do radians in purple. So to start off, we're going to start with 0 radians. And we're going to slowly work our way up. 30 degrees we discussed was pi over 6 radians. 45 was pi over 4 radians. This was pi over 3 radians. And now here's where some of the tricks start coming in. There's a lot of tricks on how to fill out the unit circle. I always like to start out with the 30, 60, 90s and work my way around, and then go back through and do the 45s. We know that each 30-degree angle is a new pi over 6. So it's going to be pi over 6, 2 pi over 6, which reduces, 3 pi over 6, which reduces, 4 pi over 6, which reduces, 5 pi over 6, which doesn't reduce, 6 pi over 6, which does, 7 pi over 6, 8 pi over 6, which does reduce, 9 pi over 6, which does, 10 pi over 6, which does, 11 pi, and 12 pi over 6. And so we see that it's just counting up pi over 6s. Each 30 is a new one. And the same goes with 45/45s. So each 45-degree angle, I'm going to go up by a pi over 4. So I have pi over 4, 2 pi over 4, which reduces, 3 pi over 4, 4 pi over 4, which reduces, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Boom. And so now that we've created all the angles, the whole point of this is to find our coordinates. So let's do our coordinates in, let's see, we've done purple, we've done red. Let's actually do our coordinates in green. I want to find the coordinates of each one of these points, which was where we're pulling the information from the previous book or previous video. With our 30, 60, 90 triangle, what we're going to do is we're going to remember our coordinates and say, okay, at 30 degrees, this would be 1, 2, square root of 3. When we convert that to a radius of 1, that 1 became a 1/2, so I know that my y is going to be 1/2. That square root of 3 became the square root of 3 over 2 coordinate. And we're going to work that all the way around. So we have our square root of 3 over 2, 1/2. We know that 60 has those numbers flipped. So 1/2 and square root of 3 over 2 up here. With the 45, 45, 90, we know that we have the square root of 2 over 2 and the square root of 2 over 2. So once we get that, we're going to take those values and we're going to write them on all 4 coordinates. Now, that's because this 30 is the same as this 30. The only difference is the x value is not going to be negative. So I'm going to go ahead and real quick, go ahead and pop down all these numbers. Boom. So now that I've got all the numbers down, all I need to go through is make sure that I have the correct signage on each one of them. I know that the top quadrant is positive on both. I know the top left quadrant is only negative on the x values. Come in here and make a negative on each one of the x's. The bottom left is negative on both x and y. So all of these are all negative. And the bottom right is only negative on the y values. So I'm going to go here and throw a negative on each one of those. The last 4 that we need to fill out are our 4, I guess you would call them cardinal angles, 0, 90, 180, 360. We know that this, because the radius is equal here to the degree measure or to the triangle it creates, there's no triangle on any one of these. So it's going to be 1, 0, negative 1, 0, 0, 1, 0, negative 1. Boom. And we have the unit circle. So now that we've created the unit circle, we can start to work with a few of these relationships. And so our first set of relationships is we're going to copy down these values onto a big table that seems a little tedious, but I promise it'll have some value here in just a few minutes. So we're going to start with our degrees. So we're going to start with 0 degrees, which was 0 radians, and we're going to move our way up all the way around the unit circle. So we're going to go from 30 to 45 to 60 to 90, all the way down. So go ahead and fill that in right now. Boom. And so now that we've filled out the degrees and the radians, what we're going to do is we're also going to copy down the x, the y values, and the radius. So the whole reason why we made the coordinates on both the previous video and at the beginning of this one is so that we can set up all possible relationships between these degrees and radians, x values, y values, and radiuses. So we know that on the unit circle, the radius is all going to be 1. So all of this column is very easy to fill out. It's just going to be 1. The x and the y's, we're just going to go ahead and copy those down from our previous sheet. So at 0 degrees, our x value was 1 and our y value was 0. At 30 degrees, our x value was the square root of 3 over 2, and our y value was 1/2. Keep working our way all the way around. We had the square root of 2 over 2 and the square root of 2 over 2, 1/2 square root of 3 over 2, and then we had 0, 1, and then we started dipping into the negatives. So negative 1/2 square root of 3 over 2. And so go ahead and fill out all of these. Boom. And so now that we have those, we've got this part filled out. Now comes the part where we're filling in a part of the table that we haven't quite seen and we haven't thought about. We're going to relate each variable to each other variable. I'm going to take the y value out of these 3, and I'm going to relate it to the r value. I'm going to take the x and relate it to the r, and the y and relate it to the x. And after I relate each one of those, I'm going to flip it just so that way I have every possible combination. Y paired with r paired with y. X paired with r paired with x, y paired with x, and x paired with y. And we're going to make this the dependent variable based off of our independent variables. So this is going to be a new variable that we're going to use on our graph, and this is going to be the other variable. So we're going to have an x, comma, y, but it's a new x and a new y. So don't think of it as x and y. Think of it as a new x and a new y. So to start off, let's take a look. Our y divided by x is 0 divided by 1. Or, sorry, not y divided by x, y divided by radius. It's still going to be 0 divided by 1, so that's going to be 0. X divided by our radius is going to be 1 divided by 1, 1. Our y divided by our x is 0 divided by 1, 0. We're going to work all the way down on these, just filling out these relationships. And remember, if you end up with a radical in the denominator, just go ahead and rationalize it. So for example, like this. If I take this divided by my radius, I get 1/2. x divided by my radius, I get square root of 3 over 2. But if I take y and divide it by x, I get half divided by this, which means keep, change, flip. So 1/2 times 2 over the square root of 3. So I get 1 over the square root of 3 because the 2's are going to cancel each other out. So that 1 over the square root of 3 ends up getting rationalized to the square root of 3 over 3. And we're just going to slowly work our way down each one of these. So go ahead and fill that out real quick. Boom, and then we have that. And so now that we've gotten the basic information filled out for everything related, what we consider the front way, we're gonna find the reciprocals of those three relationships right here. So instead of taking y divided by r, we're gonna take r and divide it by y. And you'll notice on your first chart, we got a few of these values which were undefined. We're gonna encounter a lot more of these over here. Because for example, if I take r and divide it by y, my very first entry is gonna be undefined. I can't do it. If I take r divided by x, I do get one. And if I take x divided by y, again, I get another undefined. So be prepared, anytime you're dividing by a 0, we're gonna have some undefineds going ahead and filtering out this graph. So what I want you to do is I want you to go ahead and fill out this last column. Boom. And there we go. So now we have all columns filled out. We have our degrees, we have our values filled in from our table, and then we went ahead and did a few computations. So I've got a few basic relationships set up with if this is the independent variable, the variable that we choose is how many degrees, what is the relationship between the sides? I could go ahead and say, well, what is degrees, what is the x value? But what we would be doing is we'd be tracing out this circle. But instead of tracing out this circle, we'd be tracing it up and down, up and down, up and down. So we're gonna come up with a relationship a little different. How about we look at the relationship of two other variables? And this is gonna lead us to our first question. So our first question says we're gonna graph either our degrees or our radians as your x values and your y divided by r as your y values. So here's my y divided by r. I'm gonna use either degrees or radians. So let's go ahead and let's get that set up. So up top, what I'm gonna do is I'm gonna set my degrees. So I'm gonna make sure the last part of this is going to be 360 degrees or 2 pi radians. So I got top in degrees, bottom in radians, which means that if that is 360 degrees, about halfway. So I'd say, I'm actually gonna use this paper beneath it, about right there is about halfway, which means this is 180 degrees or pi radians. And if I split it even further, this is 90 degrees or pi over 2 radians. If I split that halfway between 180 is 360 is 270 or 3 pi over 2 radians. You notice how we counted up? And then each of these we can split either into halves again if we want our 45s. So 45, 135, 225. Let's see, what is that? 270 between 360 is 315. A little bit of a pause there. This is pi over 4. So 1, 2, 3 pi over 4. 4, 5 pi over 4. 6, 7 pi over 4. And then I could even, if I wanted to, split this 90 into 3 parts. And I could split that into 3060. So another 3060, another 3060, and another 3060. Which would be pi over 6 and pi over 3. So it doesn't matter which one you use. I tend to, in the beginning, put both of them, so I'd recommend that you also put both of them. So go ahead and flesh out the rest of that. Oh, and so we have all of those filled out. So now what we want to do is we are going to graph either our degrees or our radians. So here's all our x values, and we're going to graph y over r as our y values. So if we take a look at our y over r, what we notice is that this never goes above the value of 1, and it never goes below the value of -1. So it's oscillating between a 1 and a -1, no matter what that is going to be the equivalent of. And so let's go ahead and plot a few of the points that we see. So at 0, it is 0, and I'm going to do our graph in red. So at 0, it's 0. I can do this one. So at 30 degrees, it's approximately 1/2, so about halfway up. We'll have to evaluate what the equivalents of these are later. but at 90, I know I'm at 1. And then at 150, I'm at 1/2. 180, I'm at 0. At 210, I'm at -1/2, so about right there. And then as I keep going down, at 270, I'm at -1. My last one, 330, I'm at -1/2. And we know 360 is the loop of this, so we know that we're going to end right back at this point. And so you can already kind of see what the shape is going to be, but if you wanted to add a few more points, you could. And so I encourage you to go ahead and fill in all the points. Now, filling in some of these points, like the square root of 2/2 or the square root of 3/2, you're going to bust out a calculator. So let's go ahead and see what the equivalent of those are. So if I have something like the square root of 2/2, that's going to be about 0.7. So I know that if my 45 is at 0.7, I'm going to put that right about there. So anytime I see a square root of 2/2, 135, I'm at 0.7, so, and then I'm at -0.7. It's right about right there. And then again, the last time I hit that is at 315. And so we see that these points are just adding to this general shape that we have. And so it's neat. And let's go ahead and fill in the last sets. So now I need to, if we know square root of 2/2, let's find the square root of 3/2. So second square root of 3 divided by 2. And we get 0.86, so it's a little higher up or a little farther away from 0. So anytime I see the square root of 3/2, I'm going to do it at 0.86. So let's say right about right there. And get it 120. And I see a negative at 240 and a negative at 300. So 240, I'm going a little beyond that one at 300. And again, this definitely looks like something going on right here. So now that we've gotten these points, what we want to do is we want to connect them with a smooth, unbroken line. There we go. And that is our first trig function. Our first trig function, which involves the y over the r, let's think back to which one that is by relating it to our original one. If I look at this triangle right here, what is the y value of a triangle divided by the radius? Well, that must be the opposite over the hypotenuse. So if we know that that y over the r is the opposite over the hypotenuse, this must be a sine wave, which is f of x is the sine of x. Boom. We graphed our first trig function. So now what I want you to do is I want you to go ahead and try out number 2 and number 3 and do the same thing. But on number 3, before you connect all the dots, I want you to pause the video and unpause it because we're going to do this one together. The cosine isn't too bad. This one, y divided by x, this is going to be our tangent function. Go ahead, graph the points and then see where you're at. We'll resume when you're done, see how you did. And boom. So if you plot all the points, you'll get from 0 to 2 pi, and you'll notice that I put the 45, 90, 135. I put the 45s up top, and I put the 30s and 60s on bottom. But I got these points that they seem to be almost going up, but there's a problem here because at 90 degrees and at 270 degrees, we have our y divided by x is undefined and undefined, which means that I can't actually define it. So we're actually going to have, see how many times I can say the word actually in one sentence. We're going to have an undefined part of this graph, which means that the graph has an asymptote. So we know that in this case, our x value can't equal 90 and it can't equal 270 degrees. And then once I draw those lines, this makes it much easier to graph. What we see is the fact that we still do have something like the sine wave, but we have this little thing that bends back up. Boom. And so that is what the tangent wave looks like. We have y divided by x, we'll sit opposite over adjacent. This is a tangent wave. So it's going to be f of x is equal to tan of x. Boom. And there we go. So what we're going to do is on the last two, these are our regular trig functions. We're going to have a sine, we're going to have a cosine wave, and a tangent wave. Tangent wave being the only one that's undefined out of these three. When we flip over to the reciprocal functions with the reverse of those relationships, we're going to run into asymptotes on all three of these. So make sure you graph your points, and then where you find undefined points, go ahead and pop in a dotted line so that you can see what the pattern is between them. Otherwise, this would look something a lot like a jumping, almost like a very pointy sine wave, and that might be a little confusing. So go ahead and try these out, keeping in mind that any undefined features have asymptotes. And we'll go ahead and we'll look at the first one together. So if you want to check out number 4, go ahead, pause the video, pop in number 4, unpause it when you're done, see how well you did. Okay, and so what you see right here, ignoring this little point right there, is we have a nice little trend on each side, and we have 1, 2, and 3 asymptotes, because we notice that at the 0 and at the 360, or at the 0 and at the 2 pi, we're undefined, and we have another undefined point here at pi, which means that if we connect these values, what we're going to get is we're going to get a nice upward curve that bends towards these asymptotes. Boom, if I can actually connect the points. And so this is going to be the reverse. We know y over r would be opposite over hypotenuse. This is the hypotenuse over the opposite, or the inverse of that relationship, which means that this is going to be the cosecant, which is going to be f of x is equal to the CSC of x. And there we go. So now that you've seen those, we notice that if we were to plot these two right on top of each other, they would fit very similarly in together. In fact, that's one of the things I want you to think about, is how would the sine wave graph, if I graph them right on top of each other, look like? Think about that, try out the last two, and that's how trig functions are introduced. They're just a relationship between all sides of a triangle, and instead of taking x and y, we take degrees of rotation as our x, and we take either the height, the width, or the relationship between those as our x value. And that's it.